Hey, what's up everyone? In this video we're going to be solving the second Ethernaut challenge called Fallout. However, in this graphic right here down below we can see that there's a little typo in the word Fallout. They put a number 1 instead of the second L, and they even put a little squiggly line here to kind of draw our attention to that. So definitely a big hint of what we're going to be looking for in the contract in order to beat the level. In order to beat the level we have to claim ownership of the contract, and things that might help are being familiar with the Solidity Remix IDE. So I will be using Remix to solve this challenge. However, I'm also going to do it a second time using the same strategy we used last time, which is writing some JavaScript using Ethers.JS and also using Hardhat to test it before submitting the instance. So I'll do it both ways here. Moving on to the contract itself, at the very top we can see something that's supposed to catch our attention here as well, which is the version of Solidity. The time of this video, I think it's 0.8, around 2.5-ish, but here it's 0.6, so a few versions older. And also we have this import safe math, some state variables, allocations, owner. But here's the key right here. So we have this comment constructor. However, instead of having the constructor keyword, there's a function keyword. So in older versions of Solidity, I think it was 0.4.22 maybe. Until then, that's when you would have this syntax for constructors. You would have a function keyword, and then the function will be named after the contract, and then that'll be the constructor inside here. So I'm not sure why they put 0.6 to be honest here, because this exploit wouldn't have been possible in this version. It's only 0.4 something prior to that. But in any case, you can see right away here's the exploit. We don't even need to really deep dive into this rest of this stuff here. All we have to do is just use Remix to call this function, and then we'll become the owner of the contract. So let me go ahead and copy this here. Actually, I should mention, even though this is a exploit that you'll never really see in any contracts that are modern or written within the last few years, this kind of thing that did actually happen way back in the day. I think it was 2016 when this Ruby She contract got hacked due to the exact same exploit. So this contract was supposed to be like a Ponzi scheme. I'm not sure if it was a game or some kind of joke, but it was originally called Dynamic Pyramid, and then the developers changed it to Ruby She. And you can see in this code snippet here, they changed the contract name, but they forgot to change the name of the constructor. So that allowed anyone to become the owner. And at the time when this hack happened, they lost like 100 ETH, which wasn't worth a lot back then. ETH was only trading for a few dollars per ETH. However, at today's value, obviously that'll be a huge amount of money. So even though it seems kind of silly, you won't see it happen anymore in modern Solidity code. Still, it's kind of cool to know about it because it really was a thing at one point. So in any case, I already copied the code here. Let's go over to Remix. So Remix is a really cool browser-based IDE where you can just write Solidity code and also interact with other contracts as well, just all through the browser-based IDE here. So I'm going to paste in this code, and it's complaining that the Solidity version here isn't matching the compiler version we have here. So I could change it to match the compiler version, but if I did that, then it would actually, let me just do it and see what happens. It's going to complain that the version of safe math doesn't match as this version. But it's not complaining yet because actually there is no safe math import. If I try and compile this, it's going to complain that that import doesn't exist. So this is done as a relative import. So in order to really import this code here, we would have to actually change it from relative import to import the actual code from OpenZeppelin. So let me actually go back here to this page, and then we can actually copy the import statement and then paste it in from here. So this is where the other error I was mentioning earlier happens, where it's saying, okay, so we can't use two different versions of Solidity in each file here. So we have 0.8 in this file, the one we're importing, and we have 0.6 in our file. So that's not going to work. So the way we're going to get around that is we're going to change this to 0.8. Normally I wouldn't change the code in the contract we're supposed to be hacking, because that's not something that would happen when you're actually trying to audit the contract and test hacking it. But that's really the only way to get around it in this case. And now we're going to change this back to what we had it earlier. And we see we get some more errors though, because guess in the modern version of Solidity we're using now, we have to cast Metamask to be a payable here, since we're setting it to be the owner variable, which is payable. And it could have been, I guess, the case in version 0.6 for all I know too. I'm not sure, but either way, here we have to cast it. So let's go ahead and do that. In any case, so now we're ready to go. So it's basically the same contract, just a different version, and we just added a couple of casts to make Metamask payable just to suppress those errors there. So now if we compile it, it should work. Okay, so same idea still applies though. We have to call this function that was supposed to be a constructor but didn't become a constructor because of the typo, and then that way we become the owner. So let's see how we can do that in Remix. So we just go to this tab here, and then we want to make sure, if you don't already have it, and have your injected provider from the wallet you're using. And then the cool thing about Remix is that we can just paste in an address right here. That's actually already filled in. But if I didn't have this, of course, as you already know, you would just go to the dev console and whatever browser you're using and paste the instance address from there. You can always request a new instance if you need it. So I already have mine pasted in. So now all I have to do is hit deploy, and then we can actually interact. Oops, sorry, I didn't actually want to deploy. What am I saying? I want to do add address, pardon me. And then once you do that, you just go into this tab here that you can call and interact with any functions you want to from the contract at whatever address it is you paste it in here on whatever network you're on. So that's pretty cool. You can actually just paste in some address of some contract on whatever network you want to, and then you can just begin interacting with it through this nice GUI you have here. So let's see who the current owner is. Okay, so it's nobody. It's uninitialized. This is 0 address. So we want to become the owner. So we just have to call this function here. And wait for it to get mined, and then after that we should be the owner. The other thing I liked about the Polygon run-by is the transactions generally were faster than this network. But in any case, that wasn't too bad either. So the function transaction was fine. Let's see who the owner is now. And it's the one we have here. So, excuse me, here. So ending, let's make sure, ending in 10A09. Let's see. Yep, that's the one. So if we were to submit the instance right now, we would already have beaten the level. This is a pretty simple one, of course. But just so we can do it the same style we did it last time, so we can kind of accumulate all the levels here in our own personal repository, so we can always, look back at them and kind of study from them if we need to. I'm going to solve it again here. So let me go ahead and get a new fresh instance, just so I know that it works this way too. This also might take a moment. There it is. So just to make sure it's a fresh instance, let's go back here. We'll get rid of this one. I'll paste in the address here, do add address. And it should say the owner is some address other than mine. So yeah, once again, it's a 0 address. So now going back to over here in VS Code. So we have the same code basically that we're just similar idea to what we're doing in Remix, I should say, which is we're just calling this function called Fallout. So of course, with Ethers, you have to instance to a provider using Sepolia. We have to make a reference to our wallet, and then we have to make a reference to the contract. If you were watching the last couple of videos, or if you're very familiar with Ethers, you'll know that it takes 3 parameters: the address, the ABI, and then the wallet instance. And then I just added these gas price limit just to hopefully make sure the function call happens in a reasonable amount of time and there's no gas prediction errors. So in any case, let's go ahead and run this. I'll just need to paste in the instance here. Open up the terminal, and then I already have a node script that's going to call this script here. So here we go. Okay, it appears to have worked. So now I already have the unit test here. All we want to do is just use Hardhat to do a local mock call to the contract, and then verify that. Actually, it's not a mock call; it really is using the provider. Sorry, but yeah, I just want to make sure we kind of verify that when we call the owner function, that it's going to return my address here, and I have to, of course, again paste in the instance address here, and then run the test script. Okay, and it passed, so I'm the owner. So there you have it. This code, of course, is going to be linked down below in the description. After each video, of course, it's always going to be updated to have the latest challenge code here. And let's go ahead and submit the instance, and hopefully we'll pass it. Okay, it worked.